Hello, Ibrahim, Defna, Musa. How are you guys?
I'm fine.
Me too.
And your holiday is over. I think you are back to school, right?
No, I'm not.
Really? Not yet?
Teacher, I'm still in Turkey.
Still in Turkey.
Yes.
Why? Because of holiday or for another
Yeah,
reason?
because of holidays. There's still like holidays, like another week left.
Oh, I see. But Musa, now, did you go to school? I mean, did your school start again?
Yeah,
I see. Because your holiday is over, right?
yeah.
Okay, good. Ibrahim Abdullayev. Ibrahim, what's your name? Maka, right? Oh, you're a different boy. Maybe I think I confused it with another student. Okay, good. So, Musa, are you ready for class?
Yeah.
Take this out. Thank you. Defne, where are you now? In Izmir or Istanbul?
I'm in Izmir.
So, how is the weather? It is springtime, right?
Yeah, it's still cold, but there's lots of sun. It's sunny.
Hmm. Does it rain a lot in Izmir?
No, not genuinely, but it does rain like in a normal level. But there's only like 3 months of coldness, and the rest is just summer. So that's one thing I like about it. And like this week, for example, there was snow in Istanbul, so it affected Izmir too, and we had rain once.
Is
But there's
snow
like
in
lots of,
Istanbul?
yeah, it's new. The snow in Istanbul.
Oh no, it is March, almost April. Yeah, what
It's
can we do? I
okay.
think climate change, I think
It's
now a lot
actually
of people I'm
teacher.
hearing that.
When
Hmm,
I was a kid, I used to always like when I was a kid when I was in actually Istanbul. I lived there for like 3.5 years, and then once moved back to Izmir, then to Baku. So when I was in Istanbul, it would like rain for some reason in like September, where I wouldn't expect any like snow or sorts, and then it would not like snow all throughout, December or sorts. So firstly, I feel like just Istanbul has a different weather. It can change
yeah,
up in like very small amounts of time. Like one time you look at the sun, like it's very sunny and sorts. So like you decide to wear, shorts or like something thin. And then right before you step out of the house, like right when you step out of the house, it starts raining and gets like all windy and stuff.
yeah, I see.
So
Yeah, Turkey also it has a lot of different weather because of its geographic location. Anyway, Musa, Ibrahim, Defna, we have a few weeks left. Like how many weeks left? I think 3 weeks left, right? So we are getting close to Sasmo, and after that, I think you're going to have some rest. So just actually put a little bit more effort and try to practice as many questions as possible, and also past papers. The questions, as you know, from 16 to 25, right? They are a little bit harder questions, and you need to practice those questions once again without looking at the solution. Can you solve those problems without any difficulty or not? Okay. So after that, I mean, if you get good results, that's good for you. That's good for your parents and for everybody. And as you see here, some small questions, they are not so hard, maybe not so easy. Just little bits. You need to practice thinking a little bit in a different way. So that means that critical thinking, right? We call this critical thinking in math. So today we are going to start this S2 2016, all right? And the last time I think S1, we did a few questions left. I'm going to do them after we finish this paper because they will take a bit long time, especially the questions from 20 to to 25, they actually take a little bit long time. So I'll just leave this to later time. Okay. So Musa, Ibrahim, Defna, now you have experience, you know how to solve the questions. Okay. So now this time, okay, let me just challenge you, okay, against time. Let me give you some time, like 2 minutes. Okay. The first 10 questions, even you should be able to solve in 1 minute if possible. And after that, if questions are not so clear or something else, then we will discuss together. First, I don't want you to give a try, and after that, let's discuss them. Okay. So let's start with the first question. And can you just answer this question in 20 seconds? All right, time starts now. Look at this and tell me the answer in 20 seconds. Musa, what is the answer? Huh?
I don't know.
You don't know. Ibrahim, Abdullah, do you have any answer?
Not yet.
Not yet. Defna?
Teacher, I also don't have an answer.
Okay, the answer is E. Just 5 second
Hmm?
question. Okay.
Uh,
Why is it so? We are just adding four positive numbers. If you look at the last number, right, it is 9,999. And if you just add one, we know that this result is greater than 40,000. But do we have any answer here greater than 40,000? All these answers are less than 40,000, right? So they cannot be the answer here. So the answer is none of the above.
but like it never was be none of the above because like it was, how to say, unexpected.
Now here we have this sum. Let's say it is S. S is, I'm sure that it is greater than even 40,000. But look at the answers here: 11,000, 10,000, 11,000, 10,000. Do we have any number greater than 40,000? So
No.
this sum cannot be equal to any of these answers. We have only one choice. One of them must be true. So the answer is E. Because sometimes also multiple choice question, they have some different technique, right, to solve them fast. All right, that's it. Let's move to the next question. If they ask, okay, Mr. Carson, if the answer is not given, how can I solve this? At that time, if you look at the question, 9 and 99 and 999 and 9999, we should just write these numbers as 10 minus 1 and plus 100 minus 1 times 2 plus 1000 minus 1 times 3 plus 9. Sorry, here we have 10,000 minus 1 times 4. Now if you just group this mentally, here we have 10, 200, right? And 3,000, 40,000. So here we have 40,000, and here we have 40,000, 3,000, and here we have 210. Minus parts, here we have 1, and here we have minus 2, minus 3, minus 4. Their sum is 10, minus 10. That's equal to 43200. That's the answer. In case if we don't have any choices here, how to calculate fast. Of course, this a lot of calculations you should do mentally so that we can read the solution faster. Musa, read the question.
Mm, given that x is an in, integer such that minus 4 x 3 and y is a prime number, find the greatest
Musa, why
possible
are you
value.
not reading this? Musa, why are you not reading this? Negative 4 less than or equal to x less than or equal to 3. Read it again. Musa, read it again.
Minus 4 less equals 3. Wait, less equal x, and x less equals 3, and y is a prime number. Find the greatest possible value, x squared minus y squared.
Okay, what is the answer? Musa, answer this question. Find the greatest possible value of x squared. So if you are subtracting, right, that means that to get the maximum value, this x squared must be maximum minus y squared should be minimum. And what is the biggest value of x squared? What is it? It is from here, it is -4 squared, right? It is -4 squared minus, what is the minimum value? Since y is a prime number, the smallest prime number is 2. So it is 2 squared. 16 minus 4, that's equal to 12. So the answer is 12. Musa, you need to be able to answer these questions quickly. But still, if you're thinking, that means that you're not practicing much. These are very easy questions, and we practice a lot, right? About questions. Okay, next question. Ibrahim, are you here?
Yes.
Read the question.
Find the missing number x.
Okay, you have 1 minute and 45 seconds. Okay, let's think a little bit. Very easy question. Ibrahim D. Why?
Because
Because
I had a 12 and 23.
no. Musa, any answer?
Mm,
Defna, how about you?
C.
C.
Yeah.
Why?
Because like 12, 23, and 33, 34.
Defna, how about you? Are you there or? Okay. Look, if you notice here, Musa Ibrahim, this answers, right? This one is 169, 16, 576, and 25, and 64, 36. Do they have any common, how to say, do they have any common characteristics, or do they have any common what is it? What do they have in common? Let's say these numbers. If you look at these numbers, all of these numbers are square numbers, right? What is 36? That is 6 squared. And 64, it is 8 squared. 25, it is 5 squared. 576, that is 24 squared. 16, it is 4 squared. 169, it is 13 squared. Now, if you look at this, what is 13? 12 plus 1. What is 4? 3 plus 1. And what is 24? 23 plus 1. What is 5? 4 plus 1. And here 6, 5 plus 1. Then here x plus 1 squared is a positive number, should be 64. Right? Then what is x? X is equal to 7. Ibrahim, did you understand?
Yes.
Does it make sense?
Yes.
Oh, Maka is here. I thought you are Maka. Maka is joining now. Okay.
Hello.
Hey, Maka, I was waiting for you. I thought Ibrahim was you, but you have just joined the class. How are you, Maka? My gosh, when are we going to have a good internet connection? Let's continue. Next question. Ibrahim, read the question.
Okay. The year 2006 is an interesting number because it's one, two, three, four, six, seven, eight, and 9. What is the next number which is divisible by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10?
Okay. The year 2016 is an interesting number because it is divisible by 1, 2, 3, 4, 5, 6, 7, 8, 9. And what is the next year? That is divisible by 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So that is divisible by these numbers. First, we need to find the least common multiple of these numbers. And after that, the product or multiples of that number will have the same property with the following one. I mean, the first part of the sentence. That one is this, right? So how do you find the least common multiple? What is the least common multiple of these numbers, right? So that is, I can just write, I know that all numbers are divisible by 1, so I don't have to write 1 here, and just write here 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me just do my division quickly. Divide first by 2. Here we have 1, 3, 2, 5, 3, 7, 4, 9, 5. So we have 2, right? Divide by 2. 3, 1, 5, 3, 7, 2, 9, 5. Divide by 2. Here we have 3, 5, 3, 7, 1, 9, 5. Now we don't have any even number. Now next prime number is divided by 3. Here we have 1, 5, 1, 7, 3, 5. One more time. 5, 7, 1, 5. Next prime number is 5. It is 1, 7, 1. Next prime number is 7. So here we have 1. So the least common multiple of this number is, here we have 8 and 9 and 35. What is this? 8 times 9, 72. 72 times 5, 72 times 5, that's equal to 360. And multiply this by 7, that's equal to 2,520. So one is a next year, right? Now we are in 2021. The next year will be 2,520, right? Because the least common multiple of these numbers is equal to 2520. Okay, Musa?
Yeah.
Good. Musa, read the next question.
Einstein prime is a prime number which is one less than a multiple of 3. For example, 11 is an Einstein number or Einstein prime. Sin it is one less than 12. How many Einstein prime numbers less than 60 are there?
Einstein prime is a prime number, let's say this P, which is one less than a multiple of 3. Okay, a prime number which is one less than a multiple of 3. For example, 11 is an Einstein prime since it is one less than 12, right? How many Einstein primes less than 60 are there? Okay, so to do this one simply, what is it? We have prime numbers, right? And for example, I need to write this one as all primes, right? It's a prime number which is one less than a multiple of 3. So 3 times m minus 1, it should be equal to prime number, right? So what are those numbers? Those numbers are, if I just write all the numbers, it's a lot. First, I should just list all the numbers, right? The prime numbers less than 60. And among them, we need to choose those prime numbers. What we have prime number, that's 2, right? It is 3 and 5, 7, 11, and 13. We have 17 and 19. Next one is 23, 29, 31, 37, and 41, 43, 47. And here we have 53, and let's say 59. All of them are this. So this one is 3 minus 1, so that is Einstein prime. And this one is 3. It's not, right? And this one is 3 times 2 minus 1, Einstein. And this one is 3 times no. And it's 3 times 4 minus 1, that's Einstein prime. And this one is not possible. And it's 3 times 6 minus 1, 18 minus 1, also is Einstein number. And here we have 19. Oops, 19. No, this one is 3 times 24, right? So that is also Einstein. And this one is 30 minus 1. That's also Einstein. This one is 32. No. This one is 38 minus 1. No. 42 minus 1. Yes. 42 is divisible by 3. 44 minus 1. No. 48. Yes. 54. Yes. And 60. Yes. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 Einstein primes less than 60. Maka, did we miss any number? Maka, are you here? Maka is not here. Musa?
Yes, I'm in here.
Where are you? Okay, Maka. Did we miss any number? What do you think? Did we count correctly?
Yes, maybe.
Okay, so we have 10 Einstein prime less than 60. Okay. Next question. Maka, can you read the question first?
Okay, how will the pattern appear when the transport sheet is folded along the dotted line?
What do you think, Maka? What will be your answer?
It's variant A.
A?
Yes. Or
Are you sure?
yeah, it's C maybe. A or C.
Okay. How do you do that? Usually this one is paper based and you can use your ruler, right? First, we have to just reflect this image about that dot line to do this one. For example, this point, right? It will be transformed into this point. And this point into this point. And this point into this point. So if you just join that, we will have something like this, right? And after that, it is this one. And how about this one? It will be transformed into here, right? So that will be, it is something like this, right? So what is that? Which one is it?
B.
No, 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 not like this. Okay, here. I think this is same, right? This one is, maybe you cannot see this well. This line, I think they are equal. This one, they are equal, right? So if you just reflect this also here, we will have like this. And also here. A.
Okay, it's
A, right? Because here you're just folding, right? The reflection of this picture, it will be the same thing here, right? It will be the same thing here. Okay. And after that, the reflection of these lines, they are equal, right? So which means that's, and of course, that one is not the possible case. And this one, anyway, that's it, I think. It's not so difficult question. If it's on the paper, you can just put your ruler. You can see much, much better, okay, on the screen. But here, the answer is A. Okay. Next question. Musa, read the question.
Two 10-sided dice with numbers from 1 to 10 on their faces are rolled and their faces value were multiplied. How many ways are there such that the product is a prime or ends in 6?
Did you understand the question, Musa?
Yeah.
If you understood, okay, you have 2 minutes, 2.5 minutes. Okay, everybody try. Let me see. What will be your answer? If you have answered before the time is up, please leave your answer in the chat box. Time starts now. Because we have never solved a similar question before. That's why first give a try, and after that, we will analyze together. Sona, are you here?
Oh, yeah, I am.
Good. Welcome. Yes. Who has the answer?
E.
Maybe it's B alone.
Maybe. What do you mean
Yes,
by maybe?
I think it's B.
B.
Yes.
Okay, Maka
I
says
think it's
B.
C.
Uh, oh, I didn't write in chat box. Okay, Maka, your answer is B. Sona,
Oh, my answer is C.
C. Musa,
E.
E. Ibrahim,
I got B as well.
B. Okay. Actually, we have two B's, so B's win here. The answer is B.
Sure, mine is also D.
Oh, Sona, your answer is B?
No, teacher, it's me, Daphne.
Definitely. Your answer is B?
No, D.
D. Okay, Daphne says D. Why Daphne is answer D? Is it because your name starts with D?
No, teacher. I just was like, I found first of all, I found like something else completely, but the nearest one was like D, so.
Okay. All right, let's do this quickly. Let's see. Now, two 10-sided dice with numbers from 1 to 10 on their faces are rolled and their face values were multiplied. How many ways are there such that the product is a prime or ends in 6? So the products are prime. What are these possible answers? Either it is 1, 2, right? And 1, 3, and 1, 5, and 1, 7, right? And that's it. Do we have any other possibilities? 1, 2, 1, 3, 1, 5, 1, 7. And also at the same time, actually, it can be like this, right? 2, 1, or 3, 1, and
But I didn't
5,
count
1.
it.
Say again.
Yeah, I didn't count like 2, 1, 1, 2. I just throw them away. Yeah, now I see my mistake.
Okay, in how many ways? So here we have how many? Here we have 8. It says that is prime or ends in 6. So to ends in 6, right? In product, it is like 1, 6. The product, the last digit is 6, right? It is, that's it. How about with 2, 2, 3,
8.
and 2, 8. And how about with 3, 3, 2, 3, actually already, 3, 3, no, 3, 4, 3, 5, 3, 6, 3, 8, no, 3, 9. Okay, no more, right? And how about with 4,
4,
4,
4.
4, and the 4, 6,
9.
and 4, no, not 4, 6, right?
It's 9.
4, 9. Okay. All right, see how many possibilities. Here we have 1, 2, 3, 4, 5. And here also we have 6, 1, right? And 2, 3, 2, 8, 2, 4, 4, 9, 4. But we should 4, 4 and 4, 4 is the same thing, right? We should consider this 1. So how many here? 5, it is 10. So here we have how many? It is 3, 5, it is 10. So here we have 9. But one is missing.
Teacher,
Why did
maybe
we?
we have 6, 6 too.
Oh, why didn't we count them? Sorry. Why did I start at 4? It's until 10, right? So here we have 5. It's no. With 6, right? We have 6, 6. And anything else? 6 times 7? No. 8, 9. Okay, no. How about 7? No. 7 times 7. 7 times 8. Yes. 7, 8 also, right? And 7, 9. And how about 8? No. 8, 8, and 8, 9. And that's it. Okay. So here we have also these pairs, right? And this one, I need to count this as 1, this one as 1. How many pairs do we have here? 1, 2, 3, 4, 5, 6, 7, 14. 14 minus 2. So here we have 12 pairs. So altogether it is 20. So only Daphna's answer is correct, really. Maka and the Sona. Sona, how did he calculate this? How did he count it?
I kind of use the same way as you. It's just I probably missed something. I'm not sure what I missed, but I kind of feel like I missed something.
Because your answer is C. Your answer is C, right? It's close to 820.
Yeah.
Maybe, yes, maybe you missed one number, I think. So good. So the answer is 20, I think, right? It's exactly is 20. So we have 20 different ways so that the prime is either prime or 6. Anyway, let's move to the next question. How many factors of 9800 are perfect squares? Last time we did similar question, right? It was, if you remember, how many factors of 5400 are perfect squares? Now it is 9800. Guys, try this. Okay, let me give you 2 minutes and let's see who can find the exact answer here. Maka, did you understand the question?
Yes.
Good.
Now look, it's fine the final.
Mhm.
Yeah. This kind the condoms.
Mhm.
I want these.
It is a meter tape, isn't it? Yeah. Okay, any answer?
A.
I got A.
You got A. A?
Yeah.
Me too.
Me too,
Why?
teacher.
I don't know.
How did you get it, Sona? Did you first actually find the prime factorization of this number?
Yeah, I did.
Maka, how about you?
B.
So divide by 2, right? 4900. Divide by 2, it is 2450. Divide by 2, it is 1225. Now it's not divisible by 3. The next number is divisible by 5. Divide by 5, it is 245. Divide by 5, it is 49. Divide by 7, it is 7. Divide by 7, it is 1. Okay, so we are talking about how many factors of this number are perfect squares. We know perfect squares, right? Perfect square means a number that is a square of a natural number. So by using these combinations, that the product of any numbers here, maybe 1 or 2 or 3 or all of these numbers, they are the factors of this number. Now from here, number 1 is, first we know that the smallest factor of this number is 1 because 1 is a perfect square. The second one here is this one, right? That is 4. And next one here is, what is it? It is 2 times actually 5, right? So next number is 25. And next number is 2 times 5, 2 times 5, that is 100. Next number is 2 times 7, 2 times 7, that is 14 squared. So that is 19 squared, right? So it is, no. I just skipped something, I think. Because 5 squared and also 7 squared, also it is a factor, that is 49. Then we think about its combination. Now here we have 2 times 5, that is 100. And 2 times 7, it is 14 squared, that is 196, right? And how about 2 times 5? Okay, 2 times 7. And how about 5 times 7? 5 times 7, 5 times 7, that is 35 squared. Let me just write that as 35 squared. Okay, that's 1,000 something. And how many did we count already? 1, 2, 3, 4, 5, 6, 7. So now, do we have any more?
No, I don't think so. That's it.
We have one more, Sona. We have one more. Can you see that?
Wait, really?
How about if you just combine these 3 together? That is
Oh,
2
yeah.
times 5 times 7 squared. Right? 2 times 2, 5 times 5, 7 times 7. It's also a factor. So how many? 1, 2, 3, 4, 5, 6, 7, 8. So it has 8. Okay?
Okay.
Yeah, no, I
Musa, any questions?
understand. Like, how did you get 1?
1 is 1 square, right? So
But
what is 9? 8 is divided by 1. It is 1 times 9800. So that means the 1 is a factor.
mm, thank you.
Okay. Because if you just skip this one, you get wrong answer. If you just skip the last one, they get the wrong answer. That's why deliberately actually they ask this question, because also here we have 3 pairs of these numbers and also they form a factor. Anyway, as you see, that's how to say the tricky point. So you should be careful next time. Sona, can you read the question?
Okay. In mathematics, figure 1 is called Menger sponge. The construction of Menger sponge is described as follows. First, begin with a cube. Second, subdivide the cube into 27 smaller cubes. 3. Remove the smaller cube in the middle of each face and remove the smaller cube in the very center of the larger cube, leaving 20 smaller cubes. And the surface area of the cube in step 1 is 216 centimeter square. What is the surface area of the measure sponge?
Did you understand the question, Sona?
Kind of.
Now, as you see here in figure 2, we have a cube, right? And actually it's made up of 27 smaller cubes. So now we are going to form some kind of measure sponge. Here, how we are doing this, it says that remove the smaller cube in the middle of each face. As see here, let me just use red here. I am removing this one, for example. I am removing this one, and also I'm removing this one the same way from each face. And also in the center, right, the center of the cube, we have this one smaller cube. And also we are removing from the center of the cube. And how many cubes did we remove here? 7, right? It has 6 faces. From each face, we just remove 1, and also 1 that is in the heart or in the center of this cube. And after that, we just obtain the cube in figure 1, which is called Menger sponge. So the question here is, it says the surface area, right? What is the surface area? The surface area is 6 times the area of one's, what is it? It is this one. So 6 times A, that's equal to, what is it? That's equal to 216, which means that A is equal to 216 over 6, that's equal to 36, right? So 36, how many cubes do we have here? 1, 2, 3, 4, 5, 6, 9, right? So that means that 9 times 1 square, right? Let's say 1 square, that's equal to 2 times 2, that's equal to 36. That means that just the area of one small square, right? One small square, that's 4 by 4. What is the question here? And that's the first part, because to answer this question, first we need to find one side of the smaller cube, right? The length of the smaller cube. What is the question here? What is the surface area of Menger sponge? Musa, is it clear now? Can you find it?
I'm still thinking.
Okay, Maka, did you understand the question?
Yes, but I have to think.
Okay, guys, try. Okay, I'll give you 2 minutes. After that, we'll do it together. Time starts now. وعلیکم السلام. Makkah, Makkah, why?
I don't know how did I find that.
Let's see. Sona, Ibrahim, Musa, do you have any answer? Defna, are you here still?
I have a
No.
I don't have answer.
Okay. Now Maka says 192 question answer A. Anyway, guys, actually that's a bit tricky question. I want to just say that what is the surface area of Manger sponge? First, we should understand what do we mean by surface area. Okay, if you're talking about a solid, right? Solid means three-dimensional figure. So actually, when we just say surface area, we mean its area that is in contact with the air, let's say, right? The outside medium. So outside medium means that's just air. Uh, so if you look at this one, or simply you can also understand like this figure one, if you just solve this into the water, right? What faces, what parts get wet? So now if you just look at one face, because here it's removed, right? And how many squares do we have here? 1, 2, 3, 4, 5, 6, 7, 8, right? And also touching this one, that is 9, and this one 10, and also bottom of this one 11, and this one is 12, right? So how many? Because from the center it is removed, right? Only one face it has 12. So we know the one area of the square is, what is it? It is 16. So here we have the total surface area will be, how many faces does it have? It has 6. And each faces, how many squares do we have here? As you see here, 9. This one is 10, 11, 12. Sorry, it's 1, 2, 3, 4, 8, 9, 10, 11, 12. Right? Okay, that's it. So here 6 times here we have 12. The area of each square is 4 times 4. That's equal to 16. So which is equal to uh, no. This square is, it is not 4. It is 2, right? This one is 2 by 2 square. This one is 2 by 2. So the area of one square is 4. This one is 4. Okay. So that's it. Here we have 72. 4 times 72. That's equal to 288. Right? Actually, can you see this Sona here? Why am I counting 8? Because inside is empty, right? Also, if you can see this one, the shaded part. In the same way, actually, this is the other side of this cube, the other side of this cube, and the other side of this cube. And all sides are symmetric. That's why we have how many? 6 faces. In each faces, actually, we have 12 squares. That is in contact with the air. The area of one square is 4 centimeters square. So that's why there's 288 square centimeters. Any questions, Musa?
No.
no.
Good. Yeah, let's move to the next question. That is very easy question. You have 2 minutes, okay? Guys, please do not make any mistake. And you should start solving questions correctly. Time starts now. Very easy question.
Is it D5?
Really?
It's
No.
not?
No.
Oh, well, okay, I'm gonna try another way.
We got answer from Ibrahim. Ibrahim,
Yes.
your answer is correct.
Ah.
Did you really solve it or you are just guessing the answer?
No. I didn't guess. I solved it.
Very good. I mean, if you solve this and you got this answer, good. Okay, guys, 15 seconds left.
Okay, I found it.
Makkah, no.
It's not.
Okay, it's a very easy question, right? Here, if you just notice here, triangle CDE. Let's say triangle CDE, right? And 48, one angle is 48 plus 84 plus angle E. Let's say plus angle E, that's equal to 180 degrees. Now, if you just solve this, you will find that angle E is equal to 48 degrees. What does it mean? If angle E is 48, that means that this side, right, opposite angle E, and this side opposite 48, they are equal. And the question, it says that ABCD is a square. That means that all sides are equal, right? All sides are equal. So that means that now ADE, it is an isosceles triangle. And we know that this angle is 90 degrees. So that means that if this angle is X, and also this should be X. Now from here, X plus 90 plus 84, it should be equal to 180 degrees. So now from here, what is 2x? 2x equals, take this to the right-hand side, 90 minus 84. So what is x? 6 over 2, that's equal to 3 degrees. So the answer is B. Musa,
Yes,
how
I
come
did
you
the
cannot
same.
solve this question? Yeah, so easy question, Musa. Are you tired?
I don't know.
I don't know. Who knows? Even you don't know, right? Who knows why you don't know? Okay, guys, the last question, okay, and then we will finish the class. I think you're also tired. Maka, can you read the question and answer the question for us? Let me see, 12. Okay. So we will continue from 13 next time. Maka, read the question.
Which of the statements below is true? A. The number of false statements here is 1. B. The number of false statements here is 2. C. The number of false statements here is 3. D. The number of false statements here is 4. E. The number of false statements here is 5.
What do you think, Maka?
Maybe it's D.
Which one?
D.
D. Why?
Because we have 5 statements and one of them is true, the 4 of them is false.
Good.
May
So
I? Is it E?
no. If it is E, Sona, it means that the number of false statements is 5, right? So here it says that one of them must be
Yeah.
true.
Is it D?
So the answer is D, because if it is
Yes.
E, all of these statements must be false. Right? If it is false, then also this is false. Then also the E is false. That means that the number of statements here, false statements, is not 5 then. But here, if D is telling the truth, let's say if this one is true, right? As you see here, it's telling the truth. That means all are false here. Right? Because it says that the number of false statements here is 4. Suppose that D is telling the truth. And at the time, actually, it is not 1. This is false, right? It is not 2. It is not 3. It is not 5. That means he's telling the truth. So that is, what is it? D. Okay, who is here? Ibrahim D. Okay, guys, we'll continue from here. Okay, thank you very much for your time and patience. Have a great day ahead. I will see you on Wednesday. If you have any questions, you can just drop in WhatsApp. I'll try to answer your questions. Musa, do you need more questions? Are you practicing?
Yeah, I'm practicing like one test, 2, 3 times.
Very good. Okay. Okay, Musa, keep practicing. See you on Wednesday, okay?
Okay.
Okay.
See
Bye
you
bye.
soon, teacher. Bye.
See
See you
you.
soon.
Thank you.
Goodbye.
Bye bye.
Goodbye.
Bye bye, Ibrahim.